so much for inviting me to give this talk. This is part of the research outcomes from Geoscience Australia's Exploring for the Future program. And Phil and I are giving this talk on behalf of the Darling, Curnamona, and Tullamarine project team and the collaborators. I have to confess that I made a few changes to our talk over the past few days. So if there's anything nonsense or stupid, that's my problem, nothing to do with my friends. So in this talk, we are going to share our new data, ideas, and insights on the mineral potential of the Tullamarine origin. And at the end, I will conclude that the Tullamarine origin is no longer exploration black hole, but full of opportunities for explorers in the future. Acknowledge of the country. As we all know, Albury is the land for multiple traditional custodians, including the Wiradjuri people, the Wiveru people, and also the Jetmaton people. I pay my respect to their ancestors and elders past, present, and emerging, and I celebrate the diversity of their ongoing culture on this land. The Tullamarine orogeny is a Cambrian mountain building event. The origin stretches more than 2,000 kilometers long and 300 kilometers wide. It extends from New South Wales, South Australia, Victoria, to Tasmania. The Tullamarine origin represents the first phase of the Tasmanites and the transition of the Cambrian to Phaneroic Australia. It separates the Proteroic rocks that host deposits like Olympic Dam and the Broken Hill from the younger Tasmanite rocks, which host a group of world-class copper gold deposits like Bendigo, Cobar, and Cadia. However, the Tullamarine origin is less well understood compared to either the older Proteroic rocks or the younger Tasmanites. I believe everyone in this room is interested in this question. Is the Tullamarine arc or the Tullamarine origin prospective for economic mineral systems to uncover? Let's find it out. The Tullamarine origin is the oldest phase of the Tasmanite, and it has been impacted by a series of younger geodynamic events. We have here learned a lot of the evolution history of Tasmanites from the first talk today as well as the talks yesterday. There are several pretty well-known younger orogenic events, including the Benambrian origin, the Tabaramban origin, and the Knimblan origin, plus today's Tonga and the Kermadec subduction. These distal, extensional, and contractional events continue to have an influence on the Tullamarine origin, especially on the formation and the development of the mineral systems of the region. There are several successful discoveries in the Tullamarine origin, including the porphyry copper gold systems in the Staveley Arc of the Western Victoria. But overall, the Tullamarine origin is less well understood. This table shows some of the key challenges, the scientific questions, and the knowledge gaps for mineral potential assessment of the region. They are making the Tullamarine origin a challenging terrain for explorers of the region. I mean, if we look into these problems or issues, the key problem is the paucity of data for a holistic Tullamarine origin-wide integration, which is foundational or fundamental to unlock the regional mineral potential. Between 2020 and 2024, Geoscience Australia's Exploring for the Future program deployed a large amount of resources at the Tullamarine to unravel the complexity of the regional geological evolution, including the broadband magnetotellurics to image the electrical resistivity of structures at depth, the deep crustal seismic to investigate the geological units in the deep subsurface, the airborne electrical magnetics to evaluate the resistivity features of the shallow cover, and the stratigraphic drilling program to test the models developed through the geophysics and the subsurface rock samples. as well as regional scale geochemical characterization of magmatic rocks to inform the tectonic models. And one of our key outcomes is the new solid geology basement map of the locally karst belt in western New South Wales. So these new geological, geochemical, and geophysical data sets from our project, together with the previously published works, is best explained by a single east-facing convergent margin system developed in the late Cambrian. And in addition to this continuous volcanic arc and full arc system, our interpretation also highlights a southward broadening back arc system, mainly in South Australia. This is also consistent with the previous models. So this continuous Cambrian convergent margin provides a refined exploration framework for different types of mineral systems. Let's say globally speaking, most of the porphyry copper gold deposits or all systems of the giant or large systems are developed either in the current or the paleo magmatic arcs like this. Regional scale zircon, hafnium, and oxygen isotopes can inform crustal architecture, the evolution history, and metal fertility. And based on our systematic zircon uranium lead geochronology, hafnium and oxygen isotope of zircon are used to map the evolution history of the Delamerian origin. Overall, 3 phases, including the Cambrian Delamerian arc phase, the Ordovician post-orogenic phase, and the Silurian Devonian regional extension phase are mapped out. And these time-sliced hafnium and oxygen isotope maps can identify the spatial relationships between the crustal materials, the crustal sources, and the mineral systems. For example, both the hafnium and the oxygen isotopes show the juvenile crustal components in the Sibley Arc area in Cambrian, which is consistent with its porphyry copper gold prospectivity of the region. To further understand the mineral potential of the Delamerian origin margin, it is fundamental to characterize its mineral systems, particularly their metallogenic characteristics. Our first set of samples are the legacy materials of 51 drill holes. We collected high-resolution drill core scan files like this, and microscope images, a lot of microscope images, and manual liberation analysis maps like here to study their textures, mineral assemblages, and pyrogenic sequence of these mineralized rocks. And these data and information are directly from the rocks associated with mineralization. Therefore, they can provide direct information to support and help mineral exploration of the region. We have also studied the 17 new drill holes from the New South Wales NDI Delamerian margin drilling program, as shown by the photos on the right. We have found magmatic rocks of mafic, intermediate, and felsic in composition, and different types of magmatic hydrothermal alteration styles, and hydrothermal breccias, and symmetrical hydrothermal veins with the symmetrical selvages, and of course sulfides. These metallogenic characteristics have shown similarities with the rocks from the Staveley drilling program in Western Victoria and the South Australia NDI Delamerian origin drilling program. If we put all this information together, the Delamerian origin or the Delamerian origin margin sounds like a favorable environment for different types of mineralization. In total, we characterized 22 key prospects or deposits of the region. The table on the right summarizes some of the key information, including the names of the prospect and deposit, and the commodities contained in these systems and deposits, all systems, and their possible genetic types of these mineral systems they belong to. And all this information are recorded in a report shown in the middle of the screen, and it has been released and publicly available. Feel free to download or visit. I marked the different types of manual systems with different colors and plotted them on the map of the Delamarine origin margin to demonstrate their spatial distribution of these different systems. Another important data set from our project is the geochronology of the manual systems, or manualization. 5 major metallogenic events, ranging from new petroleum to Devonian, have been identified. The ranges of them are plotted on the map in the middle. They are temporally distinct, and the Cambrian metallogenic event is widespread throughout the eastern margin of the Delamarine origin margin, and potentially the most significant from economic perspective. So in the next, I will step through this metallogenic evolution through time in the context of tectonic evolution from old to young. The mafic and the ultramafic rocks and the nickel-copper PGE mineralization are found in the Mount Arrowsmith area of northern Queensbury Belt in New South Wales. We have successfully obtained 2 ages from apatite using uranium lead isotopes. The ages are between 590 and 580 million years. And the nickel, copper, and the PGE mineralization is primarily associated with the basaltic rocks. So we have also outlined the spatial distribution of this basaltic rock package of the region on the map. This can give us indications about where to look for this type of mineralization. Nickel, copper, and PGE are listed critical minerals and strategic resources in Australia. And as we all know, most of the critical minerals are actually byproducts for different mineral systems. So it is important to conduct nanoscale analysis to review or study their content, their distribution, and deportment of these critical minerals. For example, apart from the nickel sulfide pentlandite in Mount Arrowsmith, nickel can also be enriched on the rim of the pyrite in the Mount Arrowsmith area, as what we can see from the mineral chemistry map here. We are now moving to the Cambrian. We have collected groups of ages between 505 and 494 million years from the porphyry and epithermal mineral systems in both the Lockley Karst belt in New South Wales and the Staveley Zone of Victoria. We have also got one older age from a prospect called Sherlock in South Australia. The age is around 525 million years. The 515 to 495 million year was a key interval for the development of the magmatic arc system in Delamarine. This marks a major regional metallogenic event facilitating a range of mineral systems, including the porphyry, epithermal skarn, and the VHMS mineralization. We outlined the extent of the convergent margin on the map in green color, here in green color, and the distribution of the arc rocks on the map in yellow. The arc rocks can be prospective for a series of mineral systems of magmatic and hydrothermal origin. We have also confirmed multiple commodities in these Cambrian mineral systems. Copper, gold, and zinc are the primary metals, and we have also revealed the currencies of several critical minerals, such as cobalt and indium in different sulfide minerals in these Cambrian mineral systems. Sulfur stop can be quite useful for us to understand the source of the ore materials. The photo on the left shows the sulfur stop composition of pyrite with different textures from the Scrope's Range prospect of the Lockley Karst belt in New South Wales. See, the sulfur stop compositions of the pyrite with clean surface are lower than the sulfur stop values of the pyrite with rough surface. But overall, all the values are between 0 and 4 per mole, which means there are multiple generations of magmatic sulfur involved in the formation of these sulfides in Scrope's Range in New South Wales. in our project, the newly accomplished time-space plot across the whole Delamarine by my colleague and my friend Phil Gilmore, and together with Andy Clark's locally discussed geological framework and Holly Taylor's locally discussed regional geochemical work, have paved the road for us to understand the Cambrian metallogeny of the Delamarine origin margin. And all these data sets are published and available online. And we have also got several hard copies of the data sets at Gilles' booth over there in the icebreaker room. The formation of these Cambrian mineral systems are controlled by the evolution of the Delamarine arc in the context of a continuous convergent margin setting. This means a series of geological processes, as shown by the model here, including subduction, magma generation, fractionation, and redox variation, and water extrusion, and evolution, and etc. These processes can eventually lead to the formation of a spectrum of mineral systems, like what have been outlined here. Ordovician, the 495 million years to 460 million years granitic magmatism and the related porphyry copper moly mineralization have been studied by a MINEX CRC embedded researcher, Dr. Wei Hong, in collaboration with the Geological Survey of South Australia and the University of Adelaide. This Cambrian convergent margin magmatism ended due to the Delamarine orogeny, and the Ordovician ore deposits and related granites are probably formed in a far-field extensional back arc setting related to the evolution of the early phase of the Macquarie arc. To further help explorers narrow down the search space for these Ordovician porphyry copper moly systems, we have outlined the spatial distribution of the magmatic rocks formed between 495 million years and 460 million years on this map. Now we are moving to the Silurian. The organic gold systems have been found in the Waratah layer, which is on the eastern side of the Cambrian volcanic arc and the north of the Coonabarabran Belt, as well as the central Stowaroon in Western Victoria. These organic gold systems are formed in early Silurian around 440 million years. The formation of these organic gold systems is associated with the green schist to amphibolite facet metamorphism of turbidite sequences and the activation or probably reactivation of the regional scale fault systems during the Benambrian orogeny. The organic gold deposits have a very interesting fluid history. Here is an example of sulfur stop compressions of pyrite with different textures from the Fiddler's Creek deposit of central Stowaroon in Victoria. This example can demonstrate the multiple sources of fluid involved or contributed to the formation of sulfides in the organic gold systems. As we can see from the numbers plotted on this pyrite map, the values of sulfur stops on the rim are apparently lower than the values in the middle of this sample. So the compression or the variation of sulfur stops are consistent with its textures and also the chemical compositions of the pyrite samples. Here's the mineral chemistry map, which highlights the variation of cobalt content in this pyrite sample. The rim of the pyrite has a clean surface and lower sulfur stop values, contains higher content of cobalt. But for the core of the pyrite, which has a rough surface and higher sulfur stop values, contains lower cobalt. This indicates different fluids have a very distinct capability to enrich and transport different metals. This understanding is particularly important for critical minerals. The last metallogenic event is in Devonian. We obtained a group of magmatic hydrothermal ages between 412 million years and 399 million years from several types of ore systems, including the porphyry, epithermal, and the Yinchuan-related gold mineralization. This is a newly identified metallogenic event in the Delamarine origin margin. The timing of mineralization might suggest a link to the Devonian basin formation and regional extension. The map on the right shows the distribution of Silurian to Devonian magmatic rocks along the eastern margin of the Delamarine origin. These rocks are formed between 425 and around 400 million years. And they can be found in New South Wales, in South Australia, and in Western Victoria. And they might be associated with the formation of these Devonian magmatic hydrothermal mineral systems. Mineral chemistry of sulfides can be quite helpful for us to understand the mineral potential of these Devonian mineral systems. Based on our new data, the primary or the major commodities of these Devonian systems are copper, gold, zinc, and silver. We have also highlighted the potential of several critical minerals, such as the cobalt, indium, arsenic, bismuth, and tellurium. This concludes the metallogenic evolution through time in the Delamarine origin margin. If we now put everything together, we can answer the question raised in the beginning of this talk. This table shows the 5 types of the mineral systems and their commodities spread across 5 different metallogenic events across the region. And by showing the spatial extent of magmatic rocks formed in different time intervals, we demonstrate the areas of interest for different types of mineral systems in the Delamarine origin margin. Therefore, the answer to this question is yes. The Delamarine origin margin, or Delamarine arc, is prospective for economic mineral systems, actually multiple types of mineral systems in this region. Based on what we have found so far in our project, we also developed a toolkit for explorers to identify mineral systems in the Delamarine. This includes a package of minerals and rocks for each of the all system types. And by using this toolkit, explorers can know what they potentially are dealing with in the field. I think this information is useful for explorers because the Delamarine origin margin is the mostly covered terrain and relatively data poor, which can has a big impact on its, assessing its mineral potential during exploration. This comes to the end of my talk today. I believe our studies across the Delamarine origin margin of the mainland Australia has made it go from exploration black holes to many potential exploration opportunities in the region. And our work at the Delamarine origin margin will continue in the next few years. So please stay tuned. Not yet, I'm sorry. Thanks. During our project period, we have also collected a large number of data sets to support regional exploration, including the examples shown here. And all the new data sets and results are publicly available. So if you need any further details, please feel free to scan the QR code here or just come to talk to us directly. And this is my opportunity to say a big thank you to many of our friends, collaborators, and partner organizations. Without them, it would be impossible for us to do this job. Thank you so much to all of them, and I look forward to more collaborations with all of you in the future. Thanks very much.
Thanks, Yambo. That was awesome. Do we have any questions? We've got a couple of minutes for some. John?
Thanks, Yambo. A great talk, and it's just great to see this unknown part of the world really opening up. So, and good news for GA is that they've got more money to do more work in the future. But so, a couple of questions. One, are you going to do any more work in the Delamarine? Because I think one of the great things GA does is get into these border regions where you've got border faults between the states. And so GA are able to bring areas, you know, in this case, South Australia, New South Wales, Victoria, and bring that together. And my second question is, on that basis, I've never seen a unified depth to basement map for that area that's crossing Victoria, New South Wales, South Australia. We've got one for New South Wales. I presume the other states haven't, but I've never seen one brought together, and I'm just wondering, that could be really useful for explorers to sort of get a handle on where they can, they've got accessible, depth to colour.
Oh, thanks very much, John. Very good questions, really to the points. Yes, I'm pretty happy with what we have got so far during the past project, and I'm really glad that people, are thinking of, what we have done is valuable, so they are going to support us to continue our work in Tullamarine. So yeah, we have known a bit about Tullamarine. It seems we have got a lot of data set compared to before, but actually, if we really want to understand the mineral potential of each of the systems formed at different metallogenic event, we definitely need more data across the whole region, not just within a belt or a zone or within certain states. So definitely across states. I think that's our job to do. And yeah, hopefully this answers the first question. The basement map of the region, we are currently still in the planning stage of what we are going to do for this deep dive project. So we haven't formally finalized our ideas. So we are still open for different suggestions and options. Definitely, I will bring this back to GA, and then definitely it will be valuable. And also, let's say, we want to focus on big picture stuff, not only just a small occurrence or prospect or just a deposit or camp scale study. We want to see the big picture of the whole region. So, and the basement map, and also for example, the topography and the structures, as well as the geology of the basement, definitely is a key control for the formation of different types of mineral systems. So I would be very happy if we can do that in the next. But it's an opening question. So hopefully.
Richard Blewett from Withally Gold. Yambo, beautiful presentation, lovely synthesis, love your work. What would be a highlight for you from what you found? What's your captain's pick?
Very nice question. Thank you very much, Richard. Particularly thank you very much for inviting me to give this talk today. To me, compared to what we knew before this project and what we have known now, I think there are at least two highlights or very interesting data sets for us. So the first one is we confirmed the multiple generations of, the multiple metallogenic events across the whole region. And we know what kind of mineral systems, what kind of, let's say, all systems they belong to. So this is something new from our project. It's all based on the previous studies. We are stand on the shoulders of giants, of course. But we confirm this kind of like a metallogenic framework for the whole region across different time formed at different time intervals. So I think this is something I'm quite happy with. The other point is the big picture stuff. For example, we confirmed it's a continuous convergent margin across the whole Tullamarine in mainland. So, and it's based on a lot of new data sets, the different geophysical data sets, AEM, MT, as well as seismic, and the regional scale geochemistry work, the hafnium isotopes, oxygen isotopes, as well as very, very systematic uranium-lead geochronology, and Holly Taylor's regional magmatic rock geochemistry. So it's all have, we all have, let's say, a pretty solid foundation to claim that it is the continuous convergent margin. This is very fundamental, but very important for us to understand the mineral potential of the region, because convergent margin is a very favorable environment for the formation of different types of magmatic hydrothermal systems. For example, porphyry, epithermal, skarn, VMS, blah, blah. So I think that these are the two main highlights from our project. But of course, we have a lot of many other outcomes with a lot of details. Unfortunately, I'm not an expert on geophysics and geochemistry, so I can't really speak for them. But I'm sure they have also got a lot of new discoveries and new information from their data sets as well. Thank you very much.